Okay, so far we've had a bunch of formulas, and I'm about to introduce one last one, and I think no, actually there's one after this, but this is not the last formula, but this is the last one that's about sequences. Okay, so this is about infinite series. As opposed to in the past, you've had series that would be like 1 plus 3 plus, and I added 2 there, so I add 5 plus, now I'm going to add another 2, and that's going to make it 7. And I could keep going, right? Do you think you could add this up if I said do it up to 39? You think you could add those up? Yeah, there's a formula for that. Do you think you could add those up if I said keep going to infinity? Well, other than saying that the answer is infinity, you couldn't actually add them all up, right? But there's a way to add up an infinite series of fractions like this. Let's say I start with 2, and then I go to half of that, which is 1, and I go to half of that, which is 1/2, and I go to half of that, which is 1/4, dot, dot, dot. I can add that up, even if I continue doing it to infinity. Now, the weirdest thing is, do you get that it's going to be getting closer and closer and closer to this number? Just like I get closer to the door as I want to walk out the door. I gave that example of I got to get halfway to the door, etc. I know it's going to get closer and closer to the number, but I actually have to add an infinite number of little tiny fractions to finally get the exact answer of I got out the door. I got that 10 feet total. But I have to add an infinite number of things. If it isn't blowing you away, you're not really thinking about it. I have to add an infinite number of little fractions to finally get the answer of, like, what does this come to? I'm going to show you a formula later, and we can figure it out exactly. But let's say it comes to, like, equal 4.5. It will equal an exact number. An infinite number of little fractions added up will equal a very distinct, exact number. And it's not like short by a little bit. It's exactly there. So there's a formula for that. Now, let's talk about some other formulas that you already know, though. You actually know 4 formulas. One of them is for the nth term, like a sub n, for an arithmetic. And then there's the nth term for a geometric, a sub n equals. And then there's, when you have a list like this that's distinct, like ends with a certain number, to add up a series, you have adding a arithmetic series, that's s sub n, and that's the one that little Friedrich did, remember? And that's the way I remember that formula, is he added the first and the last and then etc. Okay. Then the last kind is the one I just introduced yesterday, and that was adding up a geometric series. I'd like you to try to remember those 4 formulas. Let's just get you going to start with. The nth term of an arithmetic series starts with a sub n is equal to a plus, who's got that one at the tip of the tongue? Remember that one? Yep. That's for the arithmetic kind. And the geometric kind is here. And then adding up the series, the new one that I just gave you was a fraction that involved 1 minus r. All right, I'm going to pause for a minute and see if you can remember those. If you struggle to remember them a little bit, it's okay. It actually has been proven to increase your retention later when I tell you what the answer is. So it's okay to struggle with it, like, what's that missing piece? I can't remember what the times by here or whatever. All right, I'll pause while you try to remember those. Okay, let's see if you had those. This one for geometric, let's see, Dice of Destiny, who should I call on for that? It's row 6, person 1. That would be you. There's no row 7, so you're out of the loop. What? A times r to the n minus 1. You are correct. Raise your hand if you had that one right. Good. You have a decent short-term memory then. How about the adding up a series one? That's row 6, person 4. Right here. Person with the orange on her desk. Yes, you. Do you know what the one for adding a series is? Yes, yes. If you wrote first plus last, that's cool. It gets you the idea, but does anybody know what we call the first? A plus, what do we call the last one? And we just use this formula right here. A plus D times N minus 1. There we go. Now, sometimes when you see this formula, it'll start with a 2A. Do you get that they're just adding those two together? All right. Okay. And then the adding up a series one. That one was a little more complicated because it had this 1 minus R thing going on. Who's got the decent short-term memory and remembers yesterday's formula? Nobody bold enough? All right, what do you think?
A times 1 minus R to the n.
1 minus R to the n. I'll put that in parentheses. Over 1 minus R. You nailed it. Since that's the most recent formula, let's practice that one right now. If you use it, you won't lose it. Okay, so let's say I need a geometric series. Let's not be boring and start with 2. Let's start with 10. And then let's not be super simple and multiply by 2. Let's multiply by 3. I know it's not that much harder, but 10, and then it goes to 30, and then it goes to 90, dot, dot, dot. Now, if this was an infinite series, think about it. Do you think I could actually add up and find the answer to do infinite terms? No, other than saying the answer is infinity, you could not do it. We can with a series that is decreasing in size. Okay, and that has to do with the R. Do you get right now the R of this thing? Everybody figure out the R of this thing. Don't overthink this. What's the R for this? Say it if you know it. 3. Do you get if the R was less than 1, that the thing would actually be decreasing then? Okay, so that's your rule for a geometric that can be added up to infinity. The only way is if R is less than 1. Now, technically, this is weird, but R can be negative and less than 1 also. I'm going to explore that for a second. Let's say our R was negative a half. And I start with 10. What if R is negative a half? What does it go to next? If R is negative 1/2, it'd be negative 5. And then let's do it again. What's the next term? Positive. Isn't that weird? But it's getting smaller each time, right? Now it's positive 2.5. Now let's do it again. Multiply by negative a half. Negative, and then what the heck is half of 2.5? 1.25. And let's stop there because the decimals are going to get nasty, but I think you get the idea. It's switching between positive and negative, but it is getting smaller, 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 smaller. So only if your R is between, it's in this interval between negative 1 and 1, and notice it can't be 1. I don't know if you remember this, but if your R is 1, that just means your number repeats over and over and over and over and over again. And our formulas actually don't work for that. In this formula here, it had R cannot equal 1 in it. And if you think about that, why? Look at our formula. As soon as we put in R equals 1, do you get we have a 1 minus 1 is a 0 on the bottom? That's a problem? Okay, so bottom line, these formulas don't work if R is 1. We want our R to be between negative 1 and 1, and then we can do this new thing for the day. All right. That's just a little pre-teaching on the new thing. Now let's take this one and say, what is the 20th term? And then I'd like you to add them all up. You need one formula to figure out that. You need a different formula to figure out that. I'm going to pause for a minute and see if you can get those two. Yes, calculators would be allowed for this. Pause while you give that a shot. Okay, I'm hoping that you knew that the 20th term would be found with this formula here of the starting value A times R to the n minus 1. And A sub n, which in this case we want the 20th term, would be A, our starting amount, which is 10, times r. Our common ratio was 3 to the n minus 1, and the n in this case is 20, so 20 minus 1. So 3 to the 19th, and then you times it by 10. That's a really big number. Okay, so our 20th term all by itself is huge. But we need it. Why did I make you find the 20th term? Because you need to know the first and the last number. Oh, maybe you don't actually. All right. That's when you're adding these up. You'd have to find the 20th term, but this is still good practice. All right, because one of the questions that would be like an R2 level question could just be find the 20th term in this sequence. All right. Now, I could make the argument that the kid could leave it like this, but if you had a calculator, you'd be expected to be able to do it, and then your answer might be in scientific notation because it's so big. Would you know what to do if it said 1.6 times 10 to the 30th? You could just write your answer like that. Do you know how a calculator would say times 10 to the whatever? E, yes. All right, so Dice of Destiny, what did you actually get when you put in 10 times 3 to the 19th? So row 6, person 1, I really likes you today. Oh, you're actually reading me the number, okay. 622, and then keep going. 670? Okay. Now, did anybody get an answer of the same? Okay, a lot of people got that. That's probably it. Okay. Now, did I really need the first and the last term? No, that's on the arithmetic kind. You add the first and the last, etc. But how about on the geometric kind? No, you just have to know this formula for the geometric right here. So I'm going to put in A, our starting amount, which was 10, times 1 minus R. Well, I know R. R was 3. 1 minus 3 to the n, which is 20 terms, all over 1 minus r. As long as r isn't 1. Do you get if r was 1, that would crash the whole thing? Okay, r was 3, though, so that should work fine. So then it's 10 times this really icky number. Now, if calculators were not allowed in the test, then all I'd expect you to be able to do is to simplify this. Question? Yes. If I were to simplify this, I'd make this 2 times 5, and then I'd cancel my 2's, and then I'd have 5 times 1 minus 3 to the 20th, all over negative 1. And if it's divided by negative 1, I could just put the negative here and make it a little simpler. There you go. Now, I totally get that this will have a whole bunch of, again, it's a adding up 20 really huge numbers. It's going to be a ridiculously big number. Okay, and it may have said EE to you. So let's see what you get. Row 2, person 6. What'd you get? All right. Who did put it in? What'd you get? Times 10 to the 20th. Can anybody verify that answer? Oh, 10 to the 10th. Can anybody verify that answer? Okay, good. Lots of hands went up. All right. Now, again, it's a really, really big number. Are there big numbers like that in the world? Sure, especially when you're talking about space or huge things like, did you know that within either the last 24 hours or the next 24 hours, there's a huge 6-mile wide, I'm not sure it's a body hurtling through space, like I think it's considered a comet. Do you know what I'm talking about? Okay, we're just going to have a near miss of a 6-mile wide thing that's going to go past the Earth. Okay, now near miss, well, it's like 64 million miles away, but that's closer than the sun is to us, and in cosmic terms, that's incredibly close. So it's kind of weird, isn't that a weird concept? That's like 64 million miles away. No, wait, it actually might be like 6.4. I'm not sure. Let's look it up. I'm going to pause for a second while we find this thing. Okay, anyway, let's move on. So, the new stuff for today, remember how if your geometric series is decreasing in size, if I go from, let's say, 4, down to 2, down to 1, down to 1/2, down to what next would be next? 1/4, etc. then you can add this all up. And here's the formula. If you take A, your starting number, you divide by, I should use A, I gotta write it in general terms here, A, and you divide by 1 minus R. That's all there is to it. This is the easiest formula of them all. Okay, so let's do it for this sequence. If I take 4, my starting number, and I divide by 1 minus the R, which is the common ratio, which in this case is what? 1/2. This is a 1/2, right? Another way to do it is 2 divided by 4 gives me 1/2, or you could say, what am I timesing by? Timesing by 1/2. Okay, so I take 4 divided by 1 minus 1/2, which makes 4 divided by 1/2, which makes 4 times 2, which makes 8. You add this up, all the infinite little parts of it, and it'll equal 8. That is a weird concept that you can add an infinite number of little tiny fractions and get an exact whole number. But it's true. And if you think about it, it's the only way you can get out the door. Because I have a finite distance from here to the door of like 10 feet. And it's actually an infinite number of little fractions that I'd add up as I get there. And I can keep it simple. I have to get halfway to the door first. And then I'm going to add to that half of that. And then I'm going to add to that half of that. And when I add to that half of that, and it's an infinite little series of fractions. And I can get to 10 feet, exactly 10 feet. If I couldn't get out the door. All right. So, well, there's one that added, this whole thing added up to 8. How about if you just start with 1/2? And then let's keep your life a little simple. We'll just say we're cutting it in half each time. So what's 1/2 turn into if you cut it in half? 1/4. And then cut that in half. 1 what? 1/8. Okay. Dot, dot, dot. Would you please use your new snappy little super simple formula? Figure out what all these fractions will add up to if I do it to infinity. Pause for a second while I try that. Okay, I think you might have got kind of a cool answer there. Let's see. What's the number that goes on top? What's it called? How about this? What's the formula? The general formula. A over 1 minus R. So when I was saying, what's that thing called on top? It's called A. All right, so I'm going to put in 1/2 over 1 minus R, which is 1 minus 1/2, which is 1/2. All right? And what's 1/2 divided by 1/2? 1 whole. This series adds up to exactly 1. Isn't that weird? Not just close to 1, not just like it rounds to 1, exactly 1. All right. I hope it bothers you a little bit because it's a weird concept to add up an infinite number of things and then come up to an exact number. All right. One other twist. Does this have an R that's normal? No, it's not normal, but it'll still work. What's that one going to add up to? Take positive 2 or 4, and then you subtract 2, and then you add back in 1, and then you subtract off 1/2, and then you add back in 1/4, and then you subtract. See what I'm saying? Adds and then subtracts, adds and subtracts. That'll add up to something exact too. Why does it work? Because its R value, the common ratio, has to be between -1 and 1, and this one is. It's between -1 and 1. What's the R in this case? False. -1/2. There you go. All right. So figure out what this one adds up to. I'm going to pause for a second while you use your snappy new formula. All right. So I'm working it out with a kid. We're going to start with our formula A minus or over 1 minus R, and our A is 4 divided by what?
0.5x goes plus
hold on, 1, and then what?
And then 1 minus 0. Or negative 0.5. 4 over 1.
Wait a minute. 1 minus negative 1/2, which really means
4 over 1.5.
4 over 1 plus 1/2, which is, I'm going to say 3/2. You people with your calculators. Okay, yeah, that's 1 1/2. But do you get, I can still do this in my head if I just keep it as a fraction, because then I can flip and multiply. And then I'm going to have 4 times, what? 2/3. And then that makes 8/3. 8/3, also known as 2 and what? 2 and 2/3. 2.6 repeating. All right. So, when will this work? Well, on any geometric sequence, true or false? False. This doesn't work on every geometric sequence. On every geometric sequence that has an R, what? Less than 1. That's not good enough. Every geometric sequence that has an R that's between -1 and +1. Okay. So it can be -1 to +1. Your R has to be in that interval. Then it'll work. Okay, so then you tell me. Am I on the right track to be able to add this up? Got fractions. You said we could add up a whole bunch of fractions and it'll... No, I didn't say that. Okay. If your R, which is this divided by this, comes out to be bigger than 1, which this would, then you can't do it because it's getting bigger and bigger. And what if you wanted to say, what does this add up to? If you add up infinite terms, you would say, I can't add it up. It approaches what? Infinity. You don't want to say it adds to infinity. There's no such thing. The answer gets close to or approaches infinity would be an okay way to say it. All right, so let's look at your homework for today. Everybody see if you can find it with me. I'll pause for a second while we do. So here we're getting close to the homework. It says find the infinite sum of each. Now this makes it look like there's something really complicated at the end here. Let's try to figure out what that's doing. Because this is just cutting it in half, cutting it in half, cutting it in half. Well, that's what this is. I want you to think about that. Do you get the formula that starts with A, our starting number, and it's times by R to the power of n? See what I mean? All right. So, can I add up this set? Well, you got to ask 2 questions. Is it geometric? Or is it just subtracting 2 each time? Because you can't add that kind up. Is this geometric? Yes. Is its R between -1 and 1? Yes, it is. Because its R is actually, what's that? 4 divided by 8 makes 1/2. So if your R, if it's geometric, and your R is less than half, then yeah, you can add it all up. Okay, and we just did that one a second ago where we started with 8, so I don't think we need to do that one again. How about this one? Can you add this one all up? I got a simple reason. It's multiplying, it's geometric, but its R has issues. Its R is bigger than 1, so that wouldn't work. All right, let's move on. Find your assignment. There it is, assignment, day 1. Okay, so this is a good question. I'm going to pause to see if I want to do this one or not. Yes, this is part of your homework. You're going to start with 32. Now, we usually start with smaller numbers, but as long as the R is less than 1, it's going to be fine. What's the next number after it goes 32 centimeters on its first swing? It goes to 24. Now, it doesn't happen to have a nice R like 1/2, but you can figure out the R, right? Once you got the R, this formula is the easiest thing in the world. A over 1 minus R. See what I mean? Super simple. All right. So yes, I'd like you to do this blue page. That'll be the first thing I want you to do from your homework, and I'll find the rest in a moment. Okay, here's the next problem that I want you to do for your homework. Part A is only weird because its common ratio is negative. I like to think of it as negative a half. Okay, and we did talk through that concept. Next, they're asking you to add this up. Okay, and that should be pretty easy. Add up this one, that should be pretty easy. All you got to do is figure out what R is, and you stick it in your little formula. Those are all easy. All right, this one's good because it gives you the answer to the question, but it doesn't give you everything in between. So then you have to use your formula and stick the answer where that should go and solve for N or R or whatever part they don't give you. So yes, you should definitely do number 5. This one's cool just because it's got square roots in it, and people think, man, that makes it so hard, but it's really not. Just don't try to get a decimal for it with the calculator. Square root of 3, just leave it as the square root of 3. Just take this divided by this, and you'll be able to tell what the common ratio is. Pretty easy. I know, it's a little weird. Then it's 1 divided by that, and it's like, whoa, why is that like that? It'll make you think, and that's good. Okay, let's move on to an arithmetic series has it. Geometric series has. Okay, well, that's a really good one. Yep, we're doing that one too. I'm pretty sure that's the last one. Let me check. Yep, we're just going up to there. We're done. Now notice it says day 2. We are not doing day 2 of this because we need to get on to a different topic tomorrow. And all you really need from today is to know how to add up a geometric, like we just did. Add up a sum of a whole big geometric series that's infinite. As long as it's R's between -1 and 1, you can use that formula. That's all there is to it. So finish it up through this pink page that says problem 3 on it, and you'll know everything you need to know for today. That's all I got for you for today.